Now we'll talk about independence and how the Bayes rule plays a role. It's another court case of Sally Clark. Sally Clark was accused to be a murderer of two of her children. It was a case in London in the 80s, and she went to prison and she served her sentence. But eventually, the analysis was done to show that she is very likely to be innocent. So we're going to do this analysis. We're going to reproduce it here. And here are some of the conditional information that we're going to use. The chances of family which are non-smokers and over 25 having a SIDS death is around 1 in 8,500. Okay. The chances of family which has already had a SIDS death having a second is around 1 in 100. So in other words, the probability that a child um, um, dies because of the SIDS, and SIDS is a syndrome, is a suffocation syndrome. It's basically when child suffocates during the sleep. So the probability that child dies because of the SIDS is 1 in 8,500. However, um, if there is one child already that died of SIDS, then the probability that the second child dies of SIDS, so the conditional probability is 1 in 800. And this is a very important piece of information that was ignored in the original court case. In the original court case, the assumption was made that the SIDS tests are independent, meaning that the probability of the second child dying of SIDS, given the first child already died of SIDS, is the same as the probability the second dies out of SIDS, which is also 1 in 8,500. Okay, so three pieces of information, one, two, and the third piece of information is that the chance of a mother killing her two children is around 1 in 1 million. So we're gonna use those three pieces of information and we're gonna use the Bayes rule to do the calculations whether she is innocent or guilty. So let's do the calculations. Um, and uh, Also, so what happened in the case? Both of the children were dead, Sally Clark's children, and she was accused of murdering both of the children. And the defense side was trying to prove that both of the children died of SIDS, and Sally Clark is not the murderer; she is not guilty. So let's calculate probability that both children died of SIDS. And we know that there is 1 in 8,500 chances of child dying of SIDS, according just to counting. It's a population population rate. And we also know that given that first child died of SIDS already, then chances of a second child dying of SIDS is much higher now. It's 1 over 100. So if you calculate those two numbers now, we get 1 in 850,000. And this 1 over 100 number comes from the genetics again. So if we know that first child died of SIDS, then we know that the first child had this genetic predisposition for this to happen. And if one of the children had this genetic predisposition, then very likely the second child is also predisposed genetically to that. And the second child has much higher chances now of dying of SIDS, now, since we know that he's likely to be genetically predisposed to that. And now if we ignore this dependent structure and we assume the independence as was done in the court case, so this is the correct way of calculating it. And that's the way that the was actually calculated in the court, and Sally Clark as a result was accused. You basically take 1 over 8,500 squared and you get 1 in 73 million chance. And now we're gonna look at this odds ratio, probability of innocent or guilty given the evidence, and probability of innocent is 1 over 850,000, assuming independence, and probability of guilty given evidence is 1 in 1 million. Again, as we stated in the previous slide. This is the base rate in the population. 1 out of 1 million mothers would kill both of her children. Okay, and now we look at this ratio. This ratio is greater than 1. It's 115. So it means she's more likely to be innocent. That's the conclusion we're going to make. More likely to be innocent. And if we convert it into the probability, you remember that probability is just 1 divided 1 plus the odds, then probability of her being guilty is 46%. So less than 50% chance that she is guilty under this independence assumption. And if we ignore independence, so I'm not sure it says that's the case when we ignore this independence, then we have, you remember, it's 1 in 73 million chances that both died of SIDS and 1 in 1 million that both died because of the murder. So we have 1 to 73 ratio. Now in this case, she is more likely. She's more likely to be guilty, and seems like evidence is very strong, 1 in 73 chances. And if you calculate this into the probability, then you have probability of her being guilty at around 90%. So very convincing number. And in this case, suspect does look guilty, and in this case, actually, court did agree with these calculations, which were incorrect.